Hello students, and welcome to the CompTIA Tech Plus exam course brought to you by Third Level Technology. I am your instructor, Jim Herby. In this episode, we're going to continue in Module 2 in the exam objectives by discussing Section 2.7. Our topic is Internet Service Types. Let's begin. We're going to begin our discussion of discussing the different Internet service types with fiber optic networking. Fiber optics is when we use cabling that will use infrared light to transmit data over the cable connection. Fiber optic cabling is used for longer distances and for customers that require high bandwidth requirements. Fiber optic is a popular internet service type because it allows us to transmit multiple types of traffic at the same time. On a single fiber optic cable, you can transmit voice, video, and internet data simultaneously. Fiber optic cabling is also very popular because it has very low signal interference and attenuation. Attenuation is when we have some type of reduction in the quality of our data signal. Because fiber optic cabling uses light as the transmission method, it is not susceptible to electromagnetic and radio interference. Fiber optic cabling is used in many different industries that require very high data throughput speeds. With fiber optic cabling, we can have data throughput that is operating in both the gigabit per second as well as the terabit per second speed. You commonly see fiber optic cabling and services for industries such as medical, educational, such as universities and campuses, as well as governmental and industrial settings. Our next internet service type is a cable modem. A cable modem is a hardware device that acts as a network bridge. When you are getting internet service at your home or small office, typically you will have either fiber optic cabling or coaxial cabling that will provide the signal to your home. But you need a way to transmit and convert that coaxial or fiber optic signal into a signal that can be used in your home. And this is what a cable modem does. A cable modem will have an interface on the back of the device that will allow the coaxial or fiber optic cable to connect to it. And then the cable modem will have other interfaces that will allow us to use Ethernet cabling or to use wireless access points to provide internet service in our home or office. Cable modem typically will be used with broadband internet access. This is where we can have multiple types of traffic being sent over the same cable over multiple frequencies. Cable modems typically operate in the gigabit per second data throughput speed. You want to be familiar with a standard called DOCSIS, D-O-C-S-I-S. This is the standard that is used with cable modem connectivity. This stands for Data over Cable Service. And DOCSIS is going to be the standard that we use with our coaxial cabling to provide our internet service in our home and small office environments. Next, we're going to discuss another wired internet service type called DSL. DSL stands for Digital Subscriber Line. And DSL is a technology that we use to allow for digital data transmission over our copper telephone lines. DSL will use a higher frequency than your standard telephone lines, so this allows both voice and data traffic to be sent over the same wire. A DSL connection will use a modem. The modem will have interfaces on the back of the device that will allow us to connect either a wireless access point or Ethernet cabling to provide the internet service to the devices in our home. A DSL network is very limited in its range. A DSL service provider will have a central office location. This will be the location where all of the data connectivity traffic will originate from. A DSL network will typically have a radius of about 2 miles or 3 kilometers. And in order to get access to DSL connectivity, you will have to be within that 2-mile range. DSL modems and technology are what we call asymmetric. That means we will have faster data throughput for downloading and slower speeds for uploading files. Your DSL data throughput will operate in both the kilobit per second and the megabit per second data throughput. Your typical range will be from 256 kilobits per second up to 52 megabits per second, depending on the device modem that you have connected in your home. You also want to be aware of the fact that DSL modems are going to be a wired technology. So your home internet provider is going to have your data throughput speeds only in that kilobit to megabit per second range. If you're using any type of streaming services or require high data ability, then DSL is not really going to be a technology that is going to benefit you. And the last wired internet service we're going to discuss is a dial-up modem. This is a network connection that will use our copper land telephone lines to carry analog signals for internet connectivity. It is strictly an analog technology. Your dial-up modems are typically used only with legacy systems, older systems, as well as remote sites that may need some type of emergency connection for data connectivity. Your dial-up modems will operate strictly in the kilobit per second data throughput, typically with a range of 56 to 320 kilobits per second. Your dial-up modem will require you to have a connector for an RJ11, a registered Jack 11 connection, that will allow your dial-up modem to connect to the existing hardwired telephone system. So we discussed a few different ways that we can have wired internet service in our home. We discussed fiber optic networking, which uses light to transmit data over a long distance cable. Cable modems, which use broadband internet, typically over coaxial cabling. DSL, which uses digital signals across our telephone landlines. And dial-up modems, which use analog signals over the existing copper telephone line connections. Now, in the second half of this episode, we're going to discuss a couple different that internet service providers can provide internet connectivity through a wireless connection. You want to be aware of radio frequency technology. Both your satellite and cellular networks, which we will discuss here in a moment, use radio frequencies to transmit their signals wirelessly through the air. Radio frequencies will have different ways that we can transmit data using what are called channels. You will have multiple available frequencies. Two common ones are the 2.4 gigahertz and the 5 gigahertz frequencies. And in each of these frequency bands, you will have channels. These will be segmented slices of the frequency that we can identify to transmit specific types of data. This can be voice, video, or data. The first wireless networking service type we're going to discuss is satellite. Satellite networking is also what we call an extraterrestrial service type. That is because we are going to use satellites that will be placed into orbit in the Earth's atmosphere to send and receive data over a wireless connection. Satellite networking will use radio frequencies and radio waves to transmit our wireless data. Our satellite networking typically will operate in both the megabit per second and the gigabit per second data throughput speeds. Satellite networking is what we call asymmetric. That means we will have faster downloading speeds and slower uploading speeds. One drawback to satellite networking is its vulnerability to bad weather. If you have severe thunderstorms, rain, or snow, this can block or really reduce the quality of the signal that is being sent through the air from our satellite dishes to user devices. Next, we're going to discuss a cellular network. A cellular network is what we use with our mobile devices such as smartphones. Your cellular networks will operate in a grid structure. You will have towers that will be placed at various points in the service provider's cellular network range, and these will be where data signals can be sent and received. Your cellular networks will also use radio frequencies to send and receive the data signals. We can use our cellular networks to also expand our connectivity options through hotspotting and tethering. Hotspotting is when we can share the cellular data internet connection from our mobile device with other users. It will require us to go into the settings of our mobile device and enable hotspotting. Once we have enabled this feature, other nearby devices can connect to the wireless network that is provided through our cellular provider. Another way we can expand our cellular network signal is through tethering. Tethering is when we can connect a laptop to our mobile smartphone through a USB connection. And then the laptop can use the smartphone's data connection for internet access. And lastly, we're going to discuss line of sight. Line of sight is a very important networking method that will allow us to have clear paths between different antennas in our wireless connections. If we are connecting to a cellular network or a satellite network, we want to make sure that we have a clear line of sight to either the tower or the aerial location of the satellite dish. Line of sight means that we should have no impediments in the signal traffic. Some common ways that we can have signal interference would be highly wooded areas where you have a lot of trees, or if your signal is blocked by other buildings that are taller than the one that your signal is originating from. One key networking component is to make sure that all of the antenna that we are using to establish a wireless connection is free from these types of obstructions. That will conclude our discussion of Section 2.7, Internet Service Types. In our next episode, we will move on to Section 2.8 in the objectives and discuss networking basics. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.